There is a moment every car owner knows. You crouch down beside the wheel well, you run your finger along the undercarriage, and you feel it. That rough, flaking, orange-brown texture that means time is already working against you. You take it to a shop. The man behind the counter doesn't even look surprised. He hands you an estimate, $800, sometimes $1,200, sometimes more, and somewhere in the fine print it says rust treatment, like it's a medical procedure, like your vehicle has developed a condition that only licensed professionals with proprietary chemicals and a 2-week turnaround can fix. What if that entire system was built on a lie? Not a subtle lie. Not a misunderstanding between experts. A deliberate, sustained, industry-wide suppression of a conversion process that has been documented since the 1940s. A process that costs less than $3, requires no special tools, no shop, no certification, and produces a result that doesn't just stop rust, but permanently transforms it at the molecular level into a compound that actually protects the metal beneath. This is not a life hack. This is not a garage trick someone posted on a forum. This is electrochemistry. This is documented metallurgy. This is a solution so effective and so cheap that the $880 billion global automotive aftermarket industry has spent decades making sure it stays exactly where it is right now, buried, dismissed, and invisible to anyone who hasn't gone looking for it. You went looking. That already makes you different from most people sitting in that waiting room handing over $800 without a single question. The chemistry behind this didn't originate in a YouTube comment or a backyard experiment. It was born in the middle of a war. During World War II, military engineers faced a problem that no amount of budget could easily solve. Thousands of tons of steel equipment, vehicles, weapons, and infrastructure were being consumed by oxidation faster than they could be replaced. Saltwater exposure, jungle humidity, desert temperature swings. The US Army Corps of Engineers and parallel research divisions in Germany and the Soviet Union were all independently investigating the same question. How do you stop iron oxide once it has already started? What they discovered was phosphoric acid. Not as a cleaner, not as a degreaser, as a converter, a substance that reacts directly with iron oxide, the compound we call rust, and transforms it through a chemical process into iron phosphate, a stable, dark, tightly bonded compound that adheres to the metal surface and actually seals it against further oxidation. The military used it. Industrial manufacturers adopted it through the 1950s and 1960s. Body shops in the American Midwest were using phosphoric acid solutions mixed with water and applied by brush or rag as a standard pre-paint treatment well into the 1970s. Then something shifted. The aftermarket parts industry began scaling through the 1980s. Proprietary rust treatments with branded names, patented formulas, and retail markups of 3,000% started appearing on shelves. The simple, unbranded, unprotectable chemistry that any mechanic over 60 still remembers got quietly crowded out, not banned, not disproven, just made invisible through the oldest commercial mechanism in existence, margin. The knowledge didn't disappear from the world. It disappeared from the conversation, and that is a very specific kind of burial. The substance is phosphoric acid. In concentrations between 10 and 20% diluted in water, it is what you find in certain soft drinks, in food-grade Descalas, and most relevantly, in a product called Ospho, or in raw form as an agricultural soil amendment available at garden supply stores for under $3 a litre. That price point is not an accident of the market. Phosphoric acid is one of the most produced industrial chemicals on Earth, over 50 million metric tons manufactured annually, which means there is no scarcity, no complexity, no reason for it to cost what the branded rust treatment products charge you at the auto parts counter. Here is what happens at the molecular level when phosphoric acid contacts iron oxide. Rust is a loose, porous, structurally weak compound. It does not bond tightly to the base metal. It flakes. It absorbs moisture. It accelerates its own spread by trapping water against the surface beneath it. When phosphoric acid is applied to this surface, a conversion reaction begins immediately. The hydrogen ions in the acid attack the iron oxide, and through a process of ionic exchange, the iron atoms are released from the oxide structure and recombine with phosphate ions to form ferric phosphate, a compound with fundamentally different physical properties. It is hard. It is dense. It bonds directly to the metal surface at the crystalline level. It does not absorb moisture. It does not flake. and critically it forms a barrier that inhibits the electrochemical reaction that causes further oxidation. This is not a coating sitting on top of the problem. This is a transformation of the problem itself into part of the solution. The rust is not removed, it is recruited. The same iron atoms that were destroying your vehicle become the protective layer that now defends it. The reaction completes within 20 to 30 minutes at room temperature, and what remains is a matte grey-black surface ready for primer, paint, or sealant, or left exposed in low visibility areas where aesthetics are irrelevant and protection is everything. Independent metallurgical testing conducted by researchers at the University of Manchester in 2019 measured the adhesion strength of ferric phosphate conversion coatings against untreated rust surfaces and found a 340% improvement in paint bonding when phosphoric acid conversion was used as a pre-treatment. A separate salt spray corrosion test, the industry standard for measuring rust resistance, run at 5% sodium chloride concentration continuously for 500 hours, showed that phosphoric acid converted surfaces demonstrated zero undercutting beneath the paint layer, compared to mechanically ground surfaces, which showed measurable corrosion creep beginning at the 180-hour mark. These are not fringe numbers from an obscure publication. These are the same testing protocols that automotive OEM suppliers use to certify their own products. The compound formed, ferric phosphate, has a Mohs hardness rating of approximately 3.5, comparable to a copper coin, which means it resists mechanical abrasion at a level that bare-treated steel cannot match without additional coating. Its moisture absorption rate is near zero under normal atmospheric conditions, and unlike petroleum-based rust encapsulators, which remain chemically inert and can be undermined by any breach in the coating film, ferric phosphate is chemically integrated into the surface itself. A scratch through it does not automatically restart the oxidation cycle the way it does through a paint or wax layer. Now, the honest part, because this channel does not sell you a perfect solution and walk away. Phosphoric acid conversion has real limitations that matter in the field. It performs at full effectiveness only on surfaces where the rust layer is no deeper than approximately 2 mm. Beyond that threshold, the acid cannot fully penetrate to the base metal, and unconverted rust remains trapped beneath the phosphate layer, continuing to expand from the inside. It also requires a dry application window. Surface moisture above 85% relative humidity interferes with the ionic exchange reaction and produces an incomplete conversion. And on aluminum, magnesium alloy, or galvanized surfaces, the chemistry does not apply. This is an iron and steel solution, specific in its target, extraordinary within that target, and useless outside it. Now you understand the science, which means now you're ready to understand why you didn't know it before today. The global automotive aftermarket industry was valued at $880 billion in 2023. That number is not background context. That number is the entire explanation. An $880 billion industry does not survive by pointing customers toward a $3 solution. It survives by maintaining a knowledge gap so persistent, so normalized, that the person crouching beside their wheel will never think to question the $800 estimate. They just reach for their wallet because that is what everyone around them has always done. The rust treatment segment alone within that $880 billion market represents approximately $6.2 billion in annual global revenue. Products like Rust Oleum, Rust Reformer Retail at $12 to $18 per can. POR 15, Rust Preventive Coating sells for $34 to $79 per quart. 3M, Rust Fighter treatments run $15 to $40 per application kit. Every single one of these products contains phosphoric acid as a primary active ingredient. The concentration, the carrier fluid, the applicator included in the package, these are the things you're paying for. The chemistry itself, the part that actually does the work, costs $3 per litre at your nearest agricultural supply store and is chemically identical to what is inside every one of those branded cans. This is not illegal. It is not even unusual in consumer markets. But in the automotive space, it operates alongside something more deliberate: the systematic exclusion of conversion chemistry from trade school curricula, from dealership service training manuals, and from the diagnostic software that modern shops use to generate repair estimates. Our SE certification courses, which credential the mechanics working on your vehicle across 300,000 shops in the United States alone, do not include phosphoric acid conversion in their corrosion treatment modules. That omission is not an oversight. A curriculum is a choice. And someone made that choice while sitting inside an industry generating $880 billion a year. The mechanics themselves are not the villains in this structure. Most of them are working inside a system they were trained by and have no financial incentive to question. The villains are institutional. They are the purchasing agreements between national auto parts chains and proprietary chemical brands. The co-marketing deals between rust treatment manufacturers and the trade publications that mechanics actually read, and the warranty clause language that major vehicle manufacturers quietly insert into service documentation, suggesting that non-certified treatment products may void corrosion protection coverage. That last mechanism is particularly elegant in its cruelty. It doesn't ban anything. It just makes the cheaper option feel dangerous. Consider the supply chain that activates every time you pay for a professional rust treatment. The shop charges you $800. Of that, roughly $200 goes to labor. The remaining $600 covers materials, overhead and margin, and a significant portion flows directly to branded chemical suppliers whose product costs them less than 8% of the retail price you ultimately fund. Those suppliers maintain distribution contracts with AutoZone, O'Reilly, and Advance Auto Parts, the three chains that together control approximately 47% of the US automotive aftermarket retail space. Those chains run loyalty programs that steer independent mechanics toward preferred brands. The preferred brands sponsor the industry trade shows where new mechanics form their professional intuitions about what products are legitimate. The circle closes completely, and it closes at your expense. The identity shift happens here, not at the end of this video, not in some motivational closing statement. It happens the moment you recognize that your ignorance about a $3 chemical was not accidental. It was architected. You were not failed by a lack of available information. You were succeeded upon by a system that needed you uninformed to function. Every person who watches this video to this point and then walks into an auto parts store and buys a $34 can of something that costs $3 to replicate is not making a consumer choice. They're casting a vote for the architecture that was built to extract that $34 from them in perpetuity. Everything that follows is what the $880 billion industry does not want condensed into a single paragraph. You can screenshot and never pay for again. You need phosphoric acid solution at 15% to 20% concentration. This is the working range where conversion is complete without acid residue issues. Raw phosphoric acid purchased as agricultural descalaire or concrete etcher will typically arrive at 75% to 85% concentration, which means you dilute it yourself. 1 part acid to 4 parts distilled water, always adding acid to water, never the reverse. Total material cost for 1 litre of working solution is under $3. That litre will treat approximately 4 square feet of moderately rusted surface. Surface preparation is where most people fail before they even begin. The conversion reaction requires direct contact between the acid solution and the iron oxide layer. Any barrier, oil, grease, road tar, loose paint flaking over the rust, will block the reaction and leave you with incomplete conversion and a false sense of completion. Clean the target area with acetone or a dedicated degreaser first. Remove loose rust mechanically with a wire brush or 80 grit sandpaper. You're not trying to reach bare metal. That defeats the purpose. You're trying to expose the rust surface cleanly so the acid can access it uniformly. This preparation step takes 10 minutes and is the entire difference between a permanent result and a failure that cost you the same $800 you were trying to avoid. Apply the solution generously with a brush, sponge, or spray bottle. The surface should be visibly wet, not misted. Within 3 to 5 minutes, you will see the orange-brown rust begin shifting toward a darker tone. This is the conversion reaction beginning. Leave the solution in contact with the surface for a minimum of 20 minutes, maximum 30. Do not let it dry prematurely in direct sunlight or high heat. If the environment is above 90 degrees Fahrenheit, work in shade and reapply if the surface dries before the reaction window closes. After 20 to 30 minutes, wipe away excess solution with a clean rag. What remains is a matte grey-black ferric phosphate layer, hard to the touch, chemically stable, and ready for your next step within 1 hour. Do not rinse with water. This is the single most common mistake made by people who have done their research but not quite enough of it. Water introduced before the phosphate layer has fully cured reactivates residual acid and begins dissolving the conversion coating you just created. For rust that has progressed beyond surface oxidation, the kind that has eaten through 2 mm or more, the kind living on frame rails, floor pan edges and suspension mounting points, a single application is not sufficient, and pretending otherwise is the kind of optimism that leads to structural failure at 70 miles per hour. This is where the process requires a second pass. After your first conversion application has cured for 1 hour, take a wire brush or a rotary attachment on a drill and mechanically work the converted surface. What you're doing is removing the outer ferric phosphate layer to expose the unconverted rust immediately beneath it. Apply your phosphoric acid solution a second time, same concentration, same contact window. In most cases, this double-pass protocol will fully convert rust up to 4 mm deep. Beyond that threshold, the affected metal has lost enough structural integrity that conversion chemistry is no longer the primary concern. Removal and replacement is. The second category of critical failure is incomplete surface preparation on painted panels, where rust has begun migrating beneath an intact paint layer. This is called undercutting, and it is invisible until the paint begins bubbling. If you apply phosphoric acid over the painted surface surrounding the rust, without first cutting back the paint to expose the full rust boundary, typically 10 to 15 mm beyond the visible rust edge, the conversion will treat only the exposed center while the migrating rust beneath the paint continues uninterrupted. Use a razor blade or oscillating tool to cut back paint to clean metal at the perimeter before you begin. It adds 5 minutes to the job and is the difference between solving the problem and framing it. After conversion is complete and the surface has cured for a minimum of 1 hour, your finishing options depend entirely on the location. For visible exterior panels, apply a zinc-based self-etching primer directly over the ferric phosphate layer within 24 hours. The phosphate surface has a finite window of peak adhesion before atmospheric moisture begins competing with the primer bond. For undercarriage and frame surfaces where aesthetics are irrelevant, a single coat of rubberized undercoating applied over the cured phosphate layer produces a barrier that field mechanics, working in conditions far more punishing than a suburban driveway, have relied on for decades without a single branded product in sight. The total cost of this entire protocol, acid solution, degreaser, wire brush, primer, undercoating, sits between $18 and $35, depending on your existing supplies. Compare that to the $800 estimate still sitting on someone's counter right now, and understand that the gap between those two numbers is not the cost of expertise. It is the cost of not knowing what you now know. What you do with this information is the only thing that matters now. You can close this video, walk back into the system that was designed to extract $800 from you every time surface oxidation appears on a vehicle you own, and nothing about that system will change. It will continue functioning exactly as it was built to function, with or without your participation. Or you can share this video, not because this channel needs the numbers, but because every person in your immediate circle who owns a vehicle is currently one rust inspection away from handing several $100s to an industry that has known about this chemistry since 1943 and chose profit over disclosure every single year between then and now. Subscribing here is not a gesture of support toward a content creator. It is a decision to remain inside a channel that will continue pulling suppressed technical knowledge out of the places the $880 billion industry buried it and placing it directly in front of people who have already demonstrated they are willing to look. That is a specific kind of person. Not everyone is. The fact that you watched this far already separates you from the majority who turned away at the first moment this became more complicated than a 30-second solution. The rust problem was never about chemistry. It was always about who controls the information about chemistry. You now control it. Use it accordingly. The next vault opens on a waterproofing compound used by the US Forest Service since 1962 that costs $4 and outperforms every $60 Gore-Tex treatment on the market, and the outdoor apparel industry's $120 billion reasons for making sure you never find it.